Hello, we're going to finish the arithmetic sequencing. So with that, the study, we're going to do the checkup 532, so you can take the test or quiz 533 after this. So a couple things we're looking at. If you look at these common differences, you want to find the common difference of the terms of arithmetic. I'm going to zoom in here. Hang on. There we go. So you have to find the common difference. So you're looking from 9 to 14, 14 to 19, 19 to 24, 24 to 29. So if you're looking at that, you can see you're adding 5 each time. So 5 would be the difference. Let's go to the next one. 53 goes to 44, goes to 35, goes to 26, goes to 17. This one is actually a negative 9. Negative 9. Negative 9 is the arithmetic sequence, okay? Because what we're doing is we're just calculating or figuring out, what did I have, 53, what did I do to it to get 44? And is that the same from 44 to 35? Yes, negative 9. Subtract negative 9. Okay? Question number 3, write the two terms of this arithmetic sequence. So here's another negative one too. So you have 15, 11, 7. What am I taking away to get 15 to 11? Well, it looks like a negative 4. Well, then the 7, if I go negative 4 from that, that would be a 3. And then go negative 4 from that, it would be actually a positive or a negative 1, because you're subtracting 4 from 3, that gives you negative 1. So those are the two terms. Let's go to number 4. What is the recursive formula for the arithmetic sequence 5, 9, 13, and 17? So what is happening to this? It is 5 to 9, it looks like you add 4. 9 to 13, add 4. And 13 to 17. Okay, so you're adding 4, but some of the recursive means, what did you start with? So on that, with that, they want you to start with the first term is 5. And they showed you 5 minus, or 9 minus 4 is, 9 minus 5 is 4. So this is how you would write that. A1 equals 5, because that's your first term, okay? A to the n would be plus 4. That's your, what did it change? What did the sequence do? What is it adding or subtracting, okay? So this is basically step forward in, when you write this, A1 is the first term. So that's what 1 means. A to the 1 is the first term. And A to the n, so any number I pick, basically I take that number, I subtract 1, but then I'm actually adding the 4. So this means it's a recursive one. It'll keep going. So when you take your sequence of 5, 9, 13, 17, you can go on forever, or you can pick the number and you can solve for it with this equation, okay? So that's what it means by recursive formula. You have to have an A1, which is your starting number. There's 5 right there. And then you have to have this 4, which is the difference, or what are you doing to change 5 to 9? You are adding 4, okay? Let's go to the next question. What is the explicit formula? Okay, the explicit formula is a little different. This is 3, 9, 15, 21, 27. So you have to know, first of all, what your first term is. So here is our explicit formula and how we write that. 3 right there is our first term. And then from there, your common difference, you need to find the common difference. So 3 to 9, 9 to 15. We see that if we take 9 minus 3, the difference is actually a 6. Okay, so the explicit formula is written like this. Here's our first term, and then we take that and add it to whatever number we're on, minus 1, and then take that times 6. Okay, so let's see if it works. If I have my first term as 3, my second term is 9. So we're going to take 2 in there. 2 minus 1 is 1. And then take that times 6. I'm adding 1/6. So see how this 9 right there, I'm adding 1/6. Where on this 15, I'm taking it and I'm adding 2 6s, which is 12, right? So there's the 3 plus the 12. These are explicit formulas, okay? Number 6, same thing. We want the explicit formula for the arithmetic sequence of a to the n equals 20 plus n minus 1 times 2. What is the 200th term? Well, they're saying the n is going to be 200. So you just need to substitute 200 in for n. And that is right there. There's our 200. So if we're looking for whatever term we're looking for, that's what gets stuck into the problem. So you take, here's our n, we stick 200 in there, stick 200 in there, and then just work it out. 200 minus 1 is 199. Take that times 2, so you might need a calculator. That's 398, and then you just add that to the 20 that your starting number is. Okay. First row represents, on an explicit formula, what's the model? The first row represents the first term, so A1 is actually 10. So here's the question. In the seating for a concert, the first row has 10 chairs. Every row after that has 2 more chairs. So you want to know what your starting number is. That's 10. What are you increasing it by? 2. So to write that formula, there is our starting number. Here is our number it increases by. Okay? The other one, how many chairs are in row 20? That's, you're just sticking your 20 in for the A's, the N, right there. The 20 will go into there, and wherever 20 needs to go is the N, will go there. So that would be 19. Take it times 2. Work it out. That's 10 plus 38, which gives you 48. So in row 20, there will be 48 chairs. Okay, so all you're using is 2 different formulas in here. One is the explicit formula, which is right here. And the other one is the recursive formula, which is right on the bottom right here. Okay, so we have the explicit formula and the recursive formula. Feel free to write those down in your math notebooks. And then here we're going to work it backwards. The arithmetic sequence has a reoccurrence formula of A1 equals 42. And A of n equals A n minus 1 minus 3. So what is the explicit formula? Because they can be interchangeable. They can be where 42 was our number that we're starting with. That goes there. And then the number you're subtracting, or that is the difference between the 2 terms, is the 3. There you go. Write those 2 formulas down in your notebook, and you can use that to take your quiz on 533. Some of those will be the same as this.